operation with polynomials, writing expressions, quadratic functions, equations. Okay, there's a lot in that domain. I'm just hitting the high points. All right. Also, utilizing the time we have. So I have two expressions, all right, forming this equation. So I have a left and right side that have to be equal. I have the product of a quadratic and a linear expression set equal to a cubic. Okay, so they have to be equal. And what they're saying is that I have this variable b as a constant. It's a number. If the equation is true, what is b? Solving for b. There's a couple different ways that we can look at this. First thing I'm going to do is I'm going to show you kind of the easy way. All right? But I want to show you another skill that may be more relevant in a similar problem that we could also use to solve this. So there's two ways to look at it. It's important to have both skills. Okay? The second one's not the easiest way to solve this, but it's an important skill that you need and that you will see. Okay? So if I have these products, if I multiply these two factors together, I should get this cubic expression. Okay? So what do I do when I have one polynomial multiplied by another polynomial? Distribute, right? So if I kind of reason through that and I look, I say, well, okay, if I start distributing everything, I should end up back here. So I need to figure out, well, what does b have to be in order to get back to this expression? Okay? So if I start multiplying some stuff, I can look and I see I've got x squared times x is x to the third. X squared gives me 3x squared. Here I get bx squared. Okay? And then I get plus 3bx minus 2x minus 6. Okay? So what I need to do is I need to focus on, okay, I've got my squared terms here, and I don't know what this value is. But at the end of this, I should end up with 6x squared. So what does b have to be so that when I combine these like terms, I end up with 6x squared? 3. Okay, so b has to be 3. Okay, that's the easy way. That's more of an inspection, distributed property method of evaluating what that is. Okay, recognizing structure. Okay, recognizing structure. Second way, second method, separate skill. Okay, so this is kind of structure and pattern recognition. Second skill is polynomial division. Polynomial division. Because if I have two things multiplied together to get something else, I can take the something else, divide one of them, and get the other thing. Okay? So if I wanted, I could rewrite this expression, this whole equation, to be 3x cubed plus 6x squared plus 7x minus 6 divided by x plus 3. Let me write that a little bit more neatly. And that will equal that quadratic. And by finding that quotient, I'll clearly see what b is. Okay? Not the easiest way for solving this particular problem, but it is a skill that you still need.
Wait, so you just took
the x plus 3, and I moved it to division on the other side instead of multiplication on this side. Okay? So it's just doing that. Okay? Now let me get back to the quadratic so I can solve for that missing value. Now, when we're doing division on the SAT, I would say 9 times out of 10, if not 100% of the time, the polynomial division, you would be able to use synthetic division. If they want you to do polynomial division, synthetic division is what they're going to want because it's faster, and the SAT is a race against the clock. Okay? It's a race against the clock. So it's a test of skills and speed. Synthetic division is a faster polynomial division. So it kind of doubles up on that. So when we're looking at synthetic division, we look at what our divisor is, okay, or dividend. We look at what our dividend is, and we want to strip out all the variables, we want to strip out all the exponents, and we want to focus on the coefficients and the constants. Okay? What is my coefficient of x to the third? 1. What's my coefficient for x squared? What's my coefficient for x? And then what's my constant? Negative 6. Okay, stripping all that out. And then what I need to do is I need to take my divisor, and I need to look at this plus 3, and to change the sign. That's going to go in this box. Okay? Negative 3. All right? Change the sign. If it was positive, start making negative. If it was negative, start making positive. Okay? Does anyone remember how we start this?
Bring the 1 down.
Bring the 1 down. Okay? Bring down the 1. Everything in the bottom row gets multiplied by negative 3. Okay? And once we multiply by negative 3, that number goes into the second row in the next spot. So negative 3 times 1 gives me negative 3. What am I going to do with everything in this row? Add. To bring it straight down. Okay? So everything in this row gets added to get the next value. So 6 plus negative 3 is 3. And then now what am I going to do with this 3? Multiply it, and then add, and then multiply, and then add. Okay? Now, when I get my division, now I have that last line is a new line of coefficients and constants. Okay? The last number is my remainder, so I don't need that because I have a remainder of 0. Woo. Now, here, this is going to be my quotient. So I have 1x squared plus 3 minus 2. So b is right. 1x squared minus 3x minus 2. Or plus 3x, sorry, not minus, plus 3x. Synthetic division. So when you're dealing with your polynomials, polynomial division, synthetic division. Okay. Yes. That one could probably be either one, and honestly, a calculator doesn't give you that much of an advantage. I would not be surprised if it was on the no calculator section. Honestly, I think taking the time to do the calculator would take up more time than you're saving from the synthetic division. All right. So, which of the following is equivalent to 16s to the 4th minus 4t squared? What are we doing to get from here to any of those options? We're factoring. Okay? So we need to factor it. Just want to factor as much as we can. Now, you get a little hint by looking at those answer options. What's the first thing you should do whenever you're factoring a polynomial? We want to factor out the GCF, which in this case is 4. Okay? So if I factor a 4 out of this polynomial, okay, I end up with 4s to the 4th minus t squared. Okay? So there we've eliminated d. Woo! Now I need to factor 4s to the 4th minus t squared. Double checking all of these is going to eat up so much time. It's a race against time. Special case polynomial. What is it? Difference of squares. You need to recognize some of those. You know those because, again, it's a race against time. You need to be able to see those patterns, those structures, those common things that show up in difference of squares is a great one to put in there because it's fast. It's fast and it's easy to trick you with a GCF. Okay? The squares. The difference of two perfect squares always factors to the sum of the roots and the difference of the roots. Okay? So then I look at those values for a squared and b squared and I square root them, and that's going to let me factor it. So I bring down my 4, but what's the square root of my first term? 2s squared. What's the square root of my second term? Just t. I'm going to have that twice. 1 plus, 1 minus. Oh. Okay, the difference of squares. Special case, perfect square trinomials. Okay, those usually show up a lot when you have something you need to expand it. Knowing how to expand a perfect square trinomial. Okay, binomial. squared. It's all about speed. Speed and accuracy. Race against the clock. So, in the polynomial above, c is a constant. If the polynomial is divisible by y minus 2, what is the value of c? When you have a polynomial divisible by another polynomial, it means it's a factor. Polynomial division is factoring. So, define the factor of y minus 2, or what value of c would let me have a factor of y minus 2. Now, when you've got variables, you got multiple variables, you've got these really high exponent values. Okay, if you don't have a GCF among all of them, you're probably going to be factoring by grouping. So you're going to be looking at your first two terms, your second two, and your last two terms, and factoring them out to get whatever it is your result is. Okay, so if I have y minus 2, I want to make sure that I get that as a factor, and what value of c would get me there. So if I look at these two, what's my GCF for my first two terms? Y to the 4th. When I factor out y to the 4th, what am I left with? Y minus 2, which is what I want. Okay? So I know that y minus 2 is a factor because I can factor that out of the first two, and I get y minus 2. Awesome. We're on the right track. So now I need to focus on this part. Negative c x y plus 6x. Okay? Well, right now I see that I have x as a GCF. Okay, so I can factor that out. But I still need to be left with y minus 2 when I'm done. Which means this positive 6 needs to turn into a negative 2. So what number can I plug in for c so that when I factor it out, and also out of the 6, I'm left with a negative 2. So I need a negative 3, which means c is going to be 3. Because the negative's already there. So I don't need to include it again. But if I have a negative 3 here, I can factor out negative 3 and the x. Negative 3x leaves me with y. Negative 3x leaves me with negative 2. The value of c is 3. Okay, so that's, again, it's looking at structure, patterns, and also just another factoring scale. A lot of factoring.
Oh wait, so you plugged in.
I plugged in 3. Because the negative's already there. The negative was part of the original problem. So I replaced c with 3. So that way I have a negative 3 that I can factor out, leaving me with a negative 2. The negative was already there. I just need to change c to a 3. What are the solutions? So x, solutions x for x squared minus 3 equals x. What do all of these answers kind of remind us of? Quadratic formula. Probably a really good indication that we'll be using quadratic formula, which is not provided for you, if I remember correctly, so you need to know it. What is my quadratic formula? Boom. Is it really hard to sing that without the rubber rowy boat? I always have to stop myself. All right, so there's our quadratic formula. All right, that lets us solve for x. All right, it allows us to get several different things. It allows us to get solutions. It allows us to find intercepts. It allows us to find zeros. All of these things are talking about what is x when y equals 0. That's what most of those boil down to. Different uses for x when y equals 0. Solutions, roots is another one. Roots, intercepts, and zeros. So those are terms you're going to see, and they all boil down to the same thing. What is x when y equals 0? And we can solve for that using quadratic formula. We can factor, we can use square root property, inverse operations. There's multiple ways that we can get to those, but those terms always boil down to the same thing. What is x when y equals 0? Now that being said, what do I have to do with this equation before I can plug anything into my quadratic formula? We need to move the x over because my equation needs to be set equal to 0. I cannot use the quadratic formula unless my equation is set equal to 0. X squared minus x minus 3. What's my value for a? 1. It's the coefficient of the squared term. What's my value for b? Negative 1. The coefficient of the linear term. What's my value for c? Negative 3. The constant term. Let's just plug in. Be careful with your signs. Because notice, we have a lot of similarities. All the denominators are the same, so I don't really need to worry about that. Okay? I've got negative 1 and positive 1. So when I start filling this out, b is negative 1. Negative b. What's that going to be? Positive 1. So I can eliminate both of those. My denominators are the same, so I don't need to worry about my denominator. The only thing that's different is my discriminant. So that's honestly the only part I have to solve. I don't even have to do the whole thing. Save yourself the time. You don't need to write everything out. Now, here's the fun thing with SAT. They know what mistakes you're going to make. They put answers that look right. And if you plug that into your calculator, there's a really, really common mistake that will get you the wrong answer. Okay? It has to do with this right here. Okay? Because if you try and plug that whole thing in your calculator, I saw it earlier today, plug the whole thing in your calculator, she forgot parentheses. So when she squared it, you gave her a negative 1 instead of a positive 1. Okay? So you need to be really careful about what you put in your calculator. Honestly, you shouldn't need your calculator for this. What's negative 1 squared? 1. Okay? What's 4 times 1 times negative 3? Okay? And then when I subtract negative 12, it becomes positive.
Wait, why is it positive?
Because I have...
Oh, never mind.
Okay. Okay? So then I end up with radical 13. That eliminates that and leaves me with d. And anything you can do to shave off time, I don't have to worry about the denominator, I don't have to actually solve anything. Look at what your answers are and just start eliminating them as you go and focus on the things you actually need. Save yourself the time so that you can focus on more challenging questions later if you need it. Okay? Or give you some extra time to go back and check. Alright? So race against the clock. Alright? If x is greater than 0 and we have 2x squared plus 3x minus 2 equals 0, what is the value of x? Okay? So, solving for x. Okay, so y equals 0, solving the quadratic. We have a multitude of methods. Factoring is the most common. If all else fails, you can use quadratic formula to get your answers here, but it's going to take 2. So you want to be proficient in factoring. It is the fastest way to get your solution. Okay? I could use the quadratic formula, but you're going to want to factor. Okay? So be good at factoring. Now I have a leading coefficient of 2, which means I'm going to have to factor by grouping. There are a couple different ways to factor when a is greater than 1. Factor by grouping is the most commonly taught. It's not exactly how I teach it. I teach it a little bit differently, but I'm going to do the factor by grouping because not all of you have any problems. So if you want another way to factor, please come see me during tutoring hours and I can show you another way if you find this one a little clunky. Okay? So I need to look at a times c. Okay? And I need to find something that multiplies to give me the product of a times c, but adds to give me my value of b. All right? So a times c is negative 4, and b is 3. So what multiplies to give me negative 4, but adds to give me 3? What multiplies to give me negative 4, but adds to give me 3? Okay? So negative 1, negative 1, 4. I'm going to take 3x, and I'm going to split it into negative x and 4x. I'm going to split this into this. But I'm going to switch the order. I'm going to do plus 4x minus x minus 2 equals 0. Okay? This is this. All right, see that? So that allows me to factor by grouping. Okay, I have these 4 terms, and if I look at my first 2, I have a greatest common factor of what? 2x, which leaves me with x plus 2. What can I factor out of here that will leave me with x plus 2? Negative 1. X plus 2 equals 0. So now that I have those factored, I have this first term and this first term, both of which have a greatest common factor of x plus 2, leaving me with 2x minus 1. Okay, those are 2 of my solutions. So I'm going to need to set both of those equal to 0 and solve. But note, this question only wants the value of x that's greater than 0. So again, to save yourself some time, it's helpful to be able to recognize patterns, recognize structures. Which of those is going to give me a negative answer?
X plus 2.
So I can ignore that. I don't have to do anything else with that. This is going to be a negative answer. Ignore it. I only want the positive answer. So we're going to do 2x minus 1 equals 0. 2x equals 1. X equals 1/2. There's all right.
Wait, is this like the same thing with the like x?
Huh? Which part? Okay, I don't have time to reteach all of factoring because there's a lot of different things for it, but I'll run through it quick. What multiplies to give me -4 and adds to give me 3? That's these 2 numbers. So I split 3x into this. Okay? Then I can factor by grouping. GCF here, and then I get 2 factors. So this right here is my quadratic factor. It would let me erase. Okay? It's my quadratic factor right here. To find my solutions, I would set both of these equal to 0. Okay? But if I set x plus 2 equal to 0, x is going to be -2. I don't want a negative answer. It wants only the positive answer. So I'm going to ignore this one. I'm going to toss this one out. Set that one equal to 0. Add 1 to the other side. Divide by 2. That gives me my solution for x. That's my only answer. So factoring, there's 4 or 5 different factoring methods. All of those were taught in Algebra 2. You are not strong on your factoring. That's something I would definitely go back and make sure that you review those skills. Okay, they're critical. So the sum of the solutions of 2x minus 1 squared equals x plus 2 squared. So I want to find the solution and I want to solve. Okay? So when I have 2 expressions squared, okay, if I want to get x by itself, well, I can just square root both sides, right? And that will get rid of my squares. I can do that, the property of equality. I can square root both sides and that'll get rid of the square. But you're ignoring a solution when you do that. You need to be really, really careful. Okay? If I have something squared equal to something else squared, when I square root both sides, yes, I still have a equals b, but I also have a equals negative b. Because when you square root something, you have a positive and a negative answer. Okay? So you have to include the fact that, hey, we're going to have a negative answer too. All right? So when I square root both of these, I end up with 2x minus 1 equals x plus 2. But I also end up with 2x minus 1 equals negative x plus 2. So I'm going to get 2 solutions. And then they want us to add those 2 solutions because it wants the sum of them. Okay? Once we get that, well, then I can just use my inverse operations, combine my like terms. Subtract x, add 1, distribute, add x, add 1, divide by 3. There's my 2 solutions, 3 and negative 1/3. 3 plus negative 1/3. You need to add those together because it says, what is the sum of the solutions? 3 plus negative 1/3. What is 3 plus negative 1/3? 2 2/3, which is 8/3. Improper fraction, 8/3. You need a common denominator in order to add, right? So this becomes 9/3. So